Hi, my name is Nadzirah Farhanah Binti Radhi. Before proceeding further, let's understand about citric acid. Citric acid derived from sugar fermentation is widely used in beverages, foods, detergents, and other industries due to its stability and solubility in water. It enhances flavor and acts as a preservative in products like soft drinks, juices, and energy drinks. Determining citric acid content in these beverages is critical for ensuring quality and regulatory compliance. This is typically done through titration. What is titration? Titration is a fundamental analytical technique used extensively in chemistry to determine the concentration of an unknown substance in a solution. It involves the precise addition of a titrant, a solution of known concentration, into a sample until a reaction between the two solutions reaches completion.
Hello, my name is Nurul Najwa Binti Hudzaimi, and I will be explaining about the theory behind titration. Titration is a process in which a standard reagent of a known concentration from a burette, which is the titrant, is added to a solution containing the analyte until the reaction between the analyte and the reagent is judged to be complete. In standardization of sodium hydroxide solution, the titrant is sodium hydroxide and the analyte is potassium hydrogen phthalate. In determination of citric acid, our titrant is also sodium hydroxide while our analyte is the soft drink sample. Here is a diagram on a titration setup. As we can see, the titrant goes in the burette and the analyte goes in the conical flask along with the suitable indicator. A white tile is usually placed under the conical flask to make it much easier to observe color changes. So, what happened during a titration? Firstly, the analyte, in our case the citric acid solution, is pipetted into the conical flask. Then, a few drops of indicator is added according to what type of analyte is in the conical flask. The titrant is added into the burette, taking note of its initial reading so we can use it for calculation later on. Then, the stopcock is released until the color of solution inside the conical flask starts to change. Note that once the color starts to change, the stopcock needs to be immediately be turned. Then, we observe the final reading of the titrant and subtract it with the initial reading. Also, note that the titrant and analyte can be switched, which means that the titrant could also be an acid and analyte could also be a base.
Hi, my name is Nurul Naemah, and I will explain the methodology in determination of citric acid in soft drinks, juices, and energy drinks.
So firstly, the objective of this study is to determine the concentration of citric acid in soft drinks, juices, and energy drinks. The apparatus used in this study is retort stand, white tile, 250 ml Allen Mayo flask, 10 ml of pipette, burette, and analytical balance. The chemical reagent used in this study is potassium hydrogen phthalate, which is KHP, sample of beverages, which is soft drinks, juices, and energy drink, distilled water, phenolphthalein indicator, in 0.1 molar sodium hydroxide. Moving on to the procedure. For the first one is standardization of sodium hydroxide solution. So firstly, prepare approximately 0.1 molar sodium hydroxide solution by dissolving the calculated amount of sodium hydroxide solution in distilled water and dilute in volumetric flask. Then, accurately weigh about 0.7 gram of KHP using an analytical balance. Next, dissolve the weight amount of KHP in 50 ml of distilled water in 250 ml Allen Mayo flask. Add 3 drops of phenolphthalein indicator to the KHP solution. In this step, the solution should remain colorless. Then, rinse the burette with a small amount of 0.1 molar sodium hydroxide solution. Then, fill the burette with sodium hydroxide solution. The recorded initial volume is 15 ml. Then, slowly titrate with sodium hydroxide solution using KHP solution while continuously swirling the flask. And lastly, Continue titrating until the pale pink color persists for about 30 seconds, indicating the end point. Next, let's look at the procedure of determination of citric acid. Firstly, allow the soft drink sample to sit in room temperature and degas the sample to remove carbon dioxide. Then, pipette for about 10 ml of the degassed soft drink into 215 ml aluminium flask. Then, add 15 ml of distilled water to the flask for dilution. Next, add 3 drops of phenolphthalein into the diluted sample solution. The solution should appear colorless, indicating an acidic environment. Next, fill the burette with the standardized sodium hydroxide solution. The initial volume for sodium hydroxide in the burette was recorded is 15 ml. Then slowly titrate the sample by adding sodium hydroxide into the aluminium flask while continuously swirling the flask. Continue adding the sodium hydroxide until a pale pink color persists for about 30 seconds, indicating the end point. Lastly, repeat the step of this titration 3 more times to obtain an accurate measurement.
So, this table 1 explains the result of standardizing the sodium hydroxide solution. The final and initial reading was recorded, and the average volume of titrant used in this titration is 34.24 ml. So, this table 2 explains the result of citric acid content in beverages. Volume of drink used in this titration is 10 ml for each sample, which is soft drinks, juices, and energy drinks. The final burette reading and initial burette reading was recorded, and the average concentration of citric acid in the drink sample is 0.0759 molar.
Hi, my name is Hazim Bin Hawari. We will proceed with result for determination of citric acid in soft juice and energy drinks. There is 2 points I will present about result. First is citric acid concentration in soft juice and energy drinks. Second is mean concentration of citric acid with SD in sample of soft juice and energy drinks. Now we will move to point number 1. That is citric acid concentration. For citric acid concentration, our result in this study show citric acid percentage range from 0.05 until 0.84%, including soft drinks, range 0.05 until 0.37%, juice drinks range 0.14 until 0.5%, and to energy drinks range 0.62 until 0.84%. This percentage are yet lower than level in natural fruits. This data can be used as a guideline for formulating health policy. For point number 2, mean concentration of citric acid, as shown in the table, the average concentration of citric acid in energy drinks were 7.3 plus minus 0.06 gram per liter. In juice drinks were 2.79 plus minus 0.04 gram per liter, and in soft drinks were 1.76 plus minus 0.04 gram per liter. The small standard deviation shows consistency of citric acid concentration in each drink style.
To sum up, the material covered has provided valuable insights into the titration process and its significance in determining citric acid content in soft drinks, juices, and energy drinks. Real-world examples of titration application in the industry were also presented. This analytical procedure, which involves neutralizing citric acid with a known solution, provides precise measurements crucial for maintaining product consistency and meeting regulatory standards. We believe that titration is a reliable and safe method when performed correctly.